Hey guys, this is EdRoh. Today we're going to be building a Web3 front-end application, which is a little different from regular front-end apps because we will be connecting to the blockchain. This app will allow us to mint tokens from a website using React, Hardhat, and Ethers to set this all up. Now, if you're new to blockchain development, you'll come to the realization that the setup for blockchain, or Web3 as they call it, is not that much different. Just like in Web 2.0, which is the name for our traditional way of interacting with websites, you have a front end and a back end. And you'll have a client in the front end trying to communicate with the back end, which has traditional servers that are owned by someone or a particular entity, and all the info is centralized in that server. However, in Web 3.0, the back end is basically the blockchain itself. And this is where you can communicate with smart contracts that live on the blockchain. So the major difference with the blockchain is that you have multiple nodes, and each node has a copy of all the info. So basically, all the nodes spread out the same information throughout all the nodes so that the info is not centralized in one location. Now, the front end can interact with one of those nodes, any node that you choose, but we use something called JSON RPC protocol, which is for the Ethereum network. And we will be talking about that today. Now let's get started by opening up a code editor and opening up our terminal. And in this terminal, I'm going to start with npx create React app. And I'm going to call this Web3. Now what this is doing is create React app is basically a package that will set up React and all the packages you need. It's a very convenient package that does all the boilerplate and setup for you. Now we'll come back when this finishes. All right, once that's installed, I'm going to change directory into Web3 and we are going to open up that. Now, once we open the folder, we're going to install as a dependency the Hardhat library. So Hardhat is a library that helps with configuration, maybe some boilerplate, a sample project, and also helps us deploy. It's a very useful package that the industry is currently using in the blockchain space. After that's installed, we are going to run npx Hardhat. Now this will set up a basic sample project for us. So we're here when it's asked, what do you want to do? We're going to create a basic sample project. We're going to set it as a root. We're going to add a git ignore, and we are going to install the sample project's dependency as recommended. And we're going to wait for that to finish. And the final thing we're going to install is going to be openzeppelin contracts, which is a nice, very convenient library that installs a lot of the standards that are used in smart contracts and is very useful. So now we finally finished our installation. It's a lot of boilerplate, a lot of setup, but we're finally ready. So the first thing we're going to do is go into our source directory and we're going to remove some of these files because they just kind of get in the way. We don't really need them. We're going to go into our index.js. We're going to delete this. We're going to delete our report web vitals import. And we're going to go into app.js. We're going to remove the import right here. And we're going to move this header. So this is just removing all the stuff that we pretty much don't need. Now what I'm going to do, I'm going to go into our contracts and we're going to start writing our smart contract. Now this view to video is not dedicated towards writing smart contracts. We're going to focus on the front end, but we'll briefly go over everything that's going on. So the first thing we're going to do is we're going to import a number of openzeppelin contracts that we installed. So this allows us to use some very useful standards. So the first thing we're going to do, we're going to change the contract greeter and call it mint example. And we are going to inherit from ERC 721 enumerable, which is a very useful standard, and also ownable. And then we're going to create a mapping. So this mapping will track the balances that we have using a little dictionary or object that will keep track based on the address and will store the number associated with that. And then we're going to create a constructor. So this constructor will initialize our contract, and we're going to give it two things, a name, and we are going to give it a symbol. And we will need to pass this into the ERC 721 because we are inheriting from the enumerable. Oops, I spelled name wrong, so name. And then we're going to pass in symbol like so. And we don't need anything in the constructor itself. And finally, we're going to create a mint function. So this mint function will provide us a way to create these particular tokens. And we are going to give it a public and payable modifiers. So in this mint function, we are going to create something called supply, and we're going to make it equal to the total supply, which is a function in the enumerable. It gives us a way to grab the total supply. And finally, we are going to just loop through using uint 256, and we are going to loop through the number of mints that we associated with. Like so. And we are finally going to call the safe mint function. And we are going to pass it a message sender, which is a global variable that allows us to figure out the address of the person that is using this mint function. And finally, we are going to keep track of the message sender's balance using the balance mapping. And we are going to increment that by 1 for every time we mint. So this is very basic. I know I went through this very briefly, but the main idea of this contract is that we're inheriting some openzeppelin standards, which provide us easy ways to have certain functions. But also we have a mint function that allows us to mint this particular token, which is in this case called mint example. And we can keep track of those tokens. Okay, we're going to save that. And I need to rename this. I'm going to call this mint example for the file name. And then we're going to go into our scripts file and we're going to change a few things. We're just going to get rid of all the comments. You can read them when you set up your project. But basically, I'm going to grab greeter. And I'm going to grab all the ones that are capitalized, and we're going to call this mint example capitalized. And I'm going to grab the lowercase ones and do the same and call it mint example with camel case. And we're going to change a few things. We're going to have get contract factory. That's going to be the same, but we are going to change the deploy. This deploy is going to take the same constructor variables that are passed in. So we need to pass in the name and we need to pass in the symbol. So to do that, we're going to go over here in the deploy. We're going to call this, let's just call it minter. And we're going to give it a symbol, which can be anything. We're just going to call it MINT, like that. And there you go. This is our sample script that allows us to deploy. It configures our Hardhat, and we can use this script to deploy our contract specifically. All right, and then finally, we're going to go to hardhatconfig.js, and we're going to add a few lines of code, and we're going to add a networks property here, and we're going to pass in Hardhat. So this allows us to create a local network that we can use and deploy our contract to. And we're going to pass it a chain ID of leet. This is basically the chain ID for a local network. They got a little cheeky with that. And from here, we can finally compile our contracts, which we are going to do with npx hardhat compile. So just like we compile our files for React, we're going to compile our contracts for use. And then finally, we're going to go and run npx hardhat node, which runs a local node so we can use them. And it creates a bunch of accounts that you can use. This is for your local network, and you can use this for testing purposes. It's very convenient. And from here, I'm going to create a second terminal with the split terminal button. You can click here in VS Code. And from here, we're going to run another command, npx Hardhat run scripts, and we are going to run our sample script file, which is sample-script.js, and we're going to run network and localhost. So this is actually deploying this particular contract to our local network, and we have the address finally. All right, so once we have that set up, we're going to go into our artifacts folder, which is where our compiled contract lives, and we're going to go into the mint.example.json. And what we're going to do is we're going to do Command A or Control A to select everything, and we're going to copy it. This is the ABI file, and this ABI file allows us to use the methods that are on this contract for our own use. And what we're going to do is go to a source directory, and we're going to create a new file, and we're going to call this mint.example ABI.json. And here I'm going to paste everything that I've created. And then what I'm going to do, I'm going to go to app.js, and I'm going to import, and we're going to call this mint.example ABI from the file I just created. So we can use this. And finally, we're going to create an address constant like so. And what we're going to do, we're going to copy the contract that we've created and deployed, because that's what we need to use specifically. And we're going to paste it over here. And now we can finally write our React code, our front-end code. It's a lot of setup, a lot of things that we need to get out of the way. So first things we're going to do, we're going to import a few things. We're going to import ethers and big number from ethers, which allows us to connect. And we're going to import useEffect, grab that, and use state, which is from React. And so the first thing we want to take care of is our connecting. We need to have a way of connecting our app to the front end, or to the blockchain essentially. So what we're first going to do is we're going to create a variable called accounts and a set accounts. So if you're new to React, so these essentially are hooks that you can use from use state. Essentially, the purpose of this is to save state if basically you save data that may change. So right now at the beginning, when the component or the page loads, this particular variable is empty. But there's a possibility later on when we connect and grab information from the blockchain, this use state can update the accounts. So that's why we are creating this. And what we're going to do is we're going to create an async function, and we're going to call this connect accounts. So this function will allow us to call our MetaMask, assuming we're using MetaMask wallet. So if people are using different wallets, this is not a tutorial for that. This is a very simple tutorial to explain MetaMask wallets and connecting to it. So that if you're using MetaMask, we can go window.ethereum. So this checks if running MetaMask. And after that, we're going to create a variable called accounts, and we are going to wait for a particular API call, and we're going to call something called window.ethereum.request. And we're going to pass in an object. So this is a very common and most important call that MetaMask has so we can connect our account. And we are going to pass in the method called request accounts. So this, not Q counts, accounts. So once we have that, we are going to set the accounts that we have received, and we're going to pass it into this state that we have created. And finally, we need a place where we actually call the function. This defines the function, but we need a place. And we want to call this function, we want to call the connect function when the page loads. And that's going to be using useEffect. And what we're going to do is we're going to call our connect accounts function at the beginning. And we do that by passing in a second parameter of empty array. So when the page loads, useEffect is going to run, and we're going to call connect accounts we're going to call MetaMask. We're going to wait for the accounts and we're going to set those particular accounts. Then next, we're going to create our minting functionality. So after we connect, we want the user to be able to mint from their account. And so we're going to create another state and we're going to call this mint amount and give it a set mint amount secondary function to change it. And we're going to use state 1. So we're going to call it with initial variable of 1. And we're going to create our handle mint function. If I can spell async correctly. Okay, so in this function, just realize I forgot to mention, async await is a way to call our functions if it's asynchronous, which means that if a call or API takes more than a small amount of time, you're going to have to wait for a response from the API. So you just have to write async and make sure you wait for those particular functions. All right, so in our handle mint, we want to do window.ethereum. It's always nice to safely check if that still exists. And in here, we're going to start using some of the ethers.js library to call. So we're going to create a provider and we're going to call ethers providers.web3 provider. And we're going to pass in window.ethereum. So what essentially this line is doing, we're using one of the providers. Providers are essentially a specific way to connect to the blockchain. And there's multiple providers that you can use, but for specifically MetaMask, you would use Web3 provider and you would pass in window.ethereum. And from there, we are going to create a signer. So anytime a call requires money or a transaction involves some kind of exchange of a token or anything that has financial value, you're going to have to sign that particular call. And we do that by grabbing provider that .get signer. And this signer will allow us confirmation from the user in the MetaMask so that they approve that transaction. And finally, we're going to create a contract variable. And we are going to use ethers again. And we're going to use the ethers contract property. And we are going to pass in a few things. We're going to pass in mint example address. So this is actually where we use the contract address. We're going to pass in mint example ABI. Oh, I have made a mistake. So we go ABI dot like so. And then we're going to pass in dot ABI because we're actually using, if you go back into the JSON, we're using this particular property. So that's why we pass in that. And finally, we're going to pass in signer. So everything we've set up is also we can pass it into the contract variable, which is important. And finally, we're going to create a try catch block so that anytime we're going to try this next step, which is going to be a response, and we're going to await contract.mint function. So now we can finally call our mint function. So we want to pass it our mint amount. However, our mint amount is an integer. However, Solidity, which is the Ethereum smart contract language that we were writing earlier, that needs to convert that into a big number. So we have to use big number.from. So that's why we imported that. So if this works, we can console log our response. And if it doesn't work, we have something called catch in JavaScript, so that if anytime this particular call fails, we are going to catch that particular error in an error object like so. And we're just going to console log the error if that happens. All right, so now we finally finished our functionality. The last thing we want to do is actually write the JSX, which is where we write essentially the HTML, CSS, which is combined, if you're not familiar with React, it's combined in this area of return, and it's called JSX instead. It's very similar to HTML, but it has some quirks. So here we're just going to write, this is how you create a mint button, just so we can see it. And we're going to pass in accounts.length. And if this exists, if accounts actually exists, basically if you're connected, once you're connected, we're going to display the buttons. We're basically going to display the mint button right here. So essentially what's happening is once we call connect accounts, which is going to trigger a prompt from the MetaMask API, and we're going to grab the accounts, and if the accounts work, we're going to set those accounts over here. MetaMask returns an array of accounts, but there's only one value in the array currently as of today. They may have added more accounts in the future, but if the account has more than one value, then you know the user has been connected. And once the user has been connected, we can create the mint button. We can show them the mint button after that happens. So that's what this is doing right here. So the logic that we need to create is we're going to create a button, and we're going to do on click like so. And we're going to do set mint amount. And we're going to do mint amount -1. So essentially what I'm going to create, give me 1 sec, is the negative button. So basically we're going to have a mint amount in the middle that is being displayed, and a negative sign that will decrease the mint amount with set mint amount like this, and a positive button after that. And we are going to do that by copying, pasting, but we're going to add a plus and add another plus right here. So we have the mint amount in the middle, a subtract button above, add button below. And then finally, we're going to copy and paste it one last time, but this one, we're going to pass in handle mint. So this, along with the mint text, is going to run this function whenever the user clicks it. So when the user clicks it, we're going to grab the mint amount, and that's going to call our contract and tell the contract to mint the token for our balance. Okay, with all that out of the way, we can finally run our application to try and test this. So we're going to run npm run start to make sure our application is working as intended. To set up our server, we can go to localhost 3000, and as you can see, we have, this is how you create a mint button text, and we have the MetaMask pop up so we can connect our account, which is beautiful. So now once I enter my password, I'm going to unlock it. And once we unlock it, we can see the mint buttons as expected. Now, once I opened up the inspector dev tools, but just so we can see what happens after. But from here, we're going to mint 2. And once we hit the mint button, we get a confirmation over here. And we can see how much gas is going to be costing and the total amount. So once we hit confirm, we get a response, and it is working as expected. If you're getting like a custom nonce error, if that didn't work, by the way, you can go over here. Over here in this account, you can go to settings, go to advanced, customize transaction on, and you would turn this on. And you would set the number of nonce, or basically the number of transactions that this account has made. Sometimes it's a weird quirk that it doesn't work automatically, but if you really need to, you can customize that. I've had that issue a couple times. Now, once we have that, we can't see our tokens yet. So we're going to go back, and what we're going to do is we're going to grab our contract address right here, copy that, and we are going to import our token. Now, I've already imported a token, and it's saying it's SUP in my case because it's kind of bugging out with it, but you should be able to see MINT in yours. So right here, once you add the contract, it's going to show in the sample script, you're going to show this in the token assets. So anytime you mint and I confirm, I'm going over here, and once we wait for that to finish, let's give it a sec. All right, and then once we're confirmed, we should see that this number increases. This should be mint. I've had a few deployment of a previous contract and it's getting imported at SUP instead. But you should see MINT if this is your first one. And you can do that by importing your contract address. It should automatically fulfill the symbol, which is MINT, and a token decimal would be 0 is what you would do. And you would add the custom token. And that's that. And that was it. So I know there's a lot of steps involved and a lot of things that you need to add and install, but I can guarantee you a lot of it is mostly the setup and the deployment configurations that you need to make to work with the blockchain. So now compared to a normal Web2 front-end application, the extra steps can be kind of a hassle, but in essence, it's not too different. There's a few extra packages here and there, but we can connect to the blockchain like we normally do with the backend. Anyways, hope you enjoyed this video. Please like, comment, and subscribe to stay tuned for more development content. Thank you.